Mrs. Elizabeth Adjeleian, Ms. Claudia Cancino, distinguished guests, ladies and gentlemen. Thank you for being present this evening as we celebrate the legacy of Dr. John Adjeleian in a manner that he would have admired. And it's through a lecture by a distinguished architect and conservationist. I invite Professor Paul Van Geel, the chair of the Department of Civil and Environmental Engineering, to welcome you.
Thank you, Jag. It's always a pleasure at this time of year, and it seems like this time of year comes quicker every year. But it's a pleasure on behalf of the Department of Civil and Environmental Engineering to welcome you to the John Adjeleian Lecture. This is an event that we look forward to because it gives us a chance to recognize a lot of things within our department. Before we continue, I would like to thank our guest speaker for coming. I'd like to also thank the Adjeleian family for coming. I'd like to recognize the Dean at the back, Dr. Dean Gubran, for attending or coming for the lecture. And I think the President may stop by in her busy schedule, but usually she finds the time to attend this lecture as well. As I mentioned, it's a time to reflect on the past year and to thank a number of individuals. The Department of Civil Engineering and Civil and Environmental Engineering continues to excel. Our enrollments are strong, and that's the reason that we excel is due to a lot of work by the faculty and staff in my department. So it's a time for me to acknowledge that the professors in the department, the staff, both in the admin office and in our labs, etc., put a tremendous effort into teaching our students and ensuring that they get a good experience while they're here at Carleton in the Department of Civil and Environmental Engineering. A lot of things have gone on in the past year. I'd like to highlight two things, I guess. One is a year ago when we had this talk, there was a gentleman by the name of Michael Blakeney here. He was a geotechnical engineer, and he was tragically killed in that bus crash that occurred at Fallowfield. And one of the things, I worked with Michael as a member of the Ottawa Geotechnical Group executive, and one of the things he had is he had a real passion for engineering, for geotechnical engineering of all areas, and he had a real passion for students, he had a real passion for helping others, and I'm sure that on that day he was probably standing at the front of the bus, largely because he probably gave up his seat for somebody else. And he always had a smile. When you talked to him, he was always welcoming and talking to people. And unfortunately, he passed away in that accident. But that's a reminder of how we remember people with that smile and with that passion for their profession and their passion for students, etc. And it's fitting, I just want to raise it that he was here last year, and he's kind of reflects somebody like John was. John always had a smile. Was always a jovial person, always was passionate about his profession, was passionate about students and all those kinds of things. So I'd just like to acknowledge that. The second thing is with student experience, we have an advisory committee that we've set up in the department that's been very helpful, extremely helpful in looking at our program and looking at different things. And we're going to be coming forward with a student experience initiative to raise some funds for that. But to give you an example of what we're doing in the department and some of the success of our students, last year the Canadian Society for Civil Engineering started a competition, and each university across Canada was allowed to submit one group of their fourth-year design project to that competition. And so we sent a group that was working in the transportation area, I think it was an LRT project, a group supervised by Professor Adjeleian, to the national competition. And who came in first place in the first competition? It was Carleton. Okay. We put people, thank you, we put a team into the solar decathlon. So there was a team that consisted of people from Carleton, from Algonquin, and from Queens. That team had to first of all apply, and then they narrowed the list down to I think 19 teams, and those teams were then invited to go down to California, and they had to assemble a place here at Algonquin, disassemble it, ship it all the way down there, reassemble it, and then they had to go through the competition. And you're talking a lot of the big name schools, both in North America and in Europe, competing in this competition. Carleton finished 6th overall, the top Canadian, not Carleton, but Team Ontario, which Carleton was a part of, finished 6th overall, and most importantly, finished 1st in the engineering. So they had different categories, and they placed with the highest ranking in engineering. Our students get involved in lots of things. Some of you might remember, if you're a graduate from our program, the concrete toboggan, the Troitsky Bridge competition in Concordia. This year, Carleton sent 6 teams. They won first place for team enthusiasm, but they also had 3 of their teams finish in the top 10. And here's a case where students are building bridges out of popsicle sticks and dental floss. And I can't remember the exact number of the weight that the first place team won, but it was like 400 kilograms or something in this little bridge that's made up of popsicle sticks and dental floss. How much was it?
It's over 3,000 kilograms.
3,000 kilograms. In what was it, 1 meter span?
Yeah, 1 meter span.
Okay. An incredible feat that these students do. But this is part of the student experience that students gain at Carleton and other universities, and it's an important part. And it's amazing to see that if you can support these students in some of these extracurricular activities, it also gets them engaged in the program, and they excel in the program, and they gain a lot from these experiences. When they leave, these are some of the things that they remember. And the last thing I want to do is or 2 things, if I might. I want to thank the committee that works tirelessly every year to put this presentation together. Jag, who chairs the committee, Halim's on the committee, Mario Santana, and I think Abbas Brahma, if I've got the membership correct, is on the committee. I appreciate their efforts. I'd also like to thank the staff in my department for all of their efforts. Kay, where's Kay? Kay does a lot of work in organizing this event. And this is the first year that we've worked closely with the University Advancement and alumni to broaden our invitation list and move to this new venue in terms of the river building. So I'd like to acknowledge that. The last thing that's an important, in addition to our speaker, is we'll follow this up with awards for our students. And we had a meeting earlier this week where one of my colleagues said, well, it's good students at the graduate level that do our research and that make us successful. And we've been very fortunate to have a large number of excellent students. Many of them are out in the audience today. And they'll be receiving awards today in recognition of that excellence. And so it is truly the excellence of those students, both our graduate students and our undergraduate students, the excellence of our faculty and staff, that make our department function as well as it does and to continue to excel both at Carleton and nationally and internationally. So with that, again, I'd like to thank you very much for coming. I hope you enjoy the presentation today, enjoy the recognition of our graduate students and their awards, and I think we have a few finger foods and food afterwards to mingle and reconnect with friends, etc. So thank you again for coming, and enjoy the talk.
Thank you, Paul. As I said earlier, this lecture series is our way of celebrating the legacy of Dr. John Adjeleian. I had the privilege of knowing John right from 1975 until he passed away in 2004. Now, this series of slides was supposed to roll, but it got frozen at that particular picture for a reason, I think. We have Halim here in the middle, and John on the left, and myself on the right. So you can see we were together from such a long time, and see the smile on the face of John. That was his perpetual face. He was always smiling, always jolly. Even if he will scold you, he will smile. John was that rare person who combined the qualities of intellect, creativity, leadership, humility, compassion, and kindness. He touched the hearts of many, and those of us who knew him were blessed in many ways. After earning a bachelor's degree in civil engineering in 1952 from McGill and an MASc in structural engineering from MIT, in 1955, John returned to Canada and set up a structural consulting firm in Ottawa, which now is known as Adjeleian, Allen and Rubelli Incorporated. His firm quickly established a reputation in the city and outside. Over the years since its inception in 1955, it has provided structural consultancy for over 3,000 different structures, some of them of great distinction and very notable, such as, for example, the Fathers of Confederation building in Charlottetown, the National Arts Center and Aviation Museum of Ottawa, and the Sky Dome of Toronto, which keeps on changing its name. John joined the then Department of Civil Engineering at Carleton in 1975, and he served as the chair of the department from 1976 until 1982, when he took retirement and was appointed emeritus professor. During his tenure as chair, he established the department as a center of excellence in teaching and research in the field of engineering, and I'm glad to note that the department thrives and grows in its stature all the time. Let me take a few moments to highlight what John's work has meant for Carleton, though. As I mentioned earlier, the firm of John Adjeleian has designed a large number of structures, many of them of outstanding quality or creativity. You may not, however, know that a majority of buildings on this campus, at Carleton campus, have been designed by his firm. They were the designers of the Tory building, the very first building to be built on this campus. Since then, his firm has designed many more buildings for Carleton, including the Loeb Building, the Southam Hall, the library, the Peterson Hall, the Davidson Dunton Tower, Robertson Hall, Stacy Building, Minto Case Building, and I must have missed a few. Certainly some more residences. John was a visionary with a unique ability to visualize how a structured form will work in harmony with the architecture. He encouraged teamwork that brought engineers and architects together, and he used to teach in the Faculty of Architecture, in the School of Architecture at Carleton. In fact, he was that rare engineer who was admired and loved by the community of architects. Of the many honors he received, John was proudest of his honorary membership in the Ontario Association of the Architects. The John Adjeleian Lecture has been established to celebrate the standard of excellence exemplified by John, and it is our way of celebrating the professional achievement of John. As I noted earlier, John had a very cordial personal and professional relationship with architects and was admired by them for his insight. It is therefore most appropriate that to deliver this year's lecture, we have with us a distinguished architect and a leading specialist in historic preservation, conservation, and restoration, and who has also worked with colleagues and students from Carleton on some challenging restoration projects, Ms. Claudia Cancino. I would like to take this opportunity to recognize some distinguished guests who are present this afternoon. We are afternoon with us. We are privileged to have among us the Ambassador for Peru to Canada, His Excellency Jose Antonio Beligna, and Cultural Attaché in the Peruvian Embassy, Mr. Jose Ortiz. And our President is going to probably join us later on. I will also like to welcome Ms. Natalie Bull, the Executive Director of Heritage Canada, the National Trust, which is a national charity that dedicates itself to ensuring that our buildings, landscapes, natural areas, and communities are widely and consistently valued as the cornerstones of our identity, memory, and the sense of place, and are recognized as essential to a vibrant economy and a sustainable future for all Canadians. I'd like to invite Ms. Bull to offer brief remarks on our heritage. Ms. Bull.
Thank you very much. It's my pleasure to be with you here today at the John Adjeleian Lecture, organized by Carleton University's Department of Civil and Environmental Engineering. I was asked to say a few words about the relationship between education and heritage conservation. My organization, the National Trust, was created in 1973 with the mandate to help Canadians and engage them in protecting the places that matter to them. And the early leaders of the organization learned very early on the essential role that the training and education play. You need people with the skills and the attitudes and the abilities to protect these places that matter to us. When I chose heritage conservation in the 1980s, or maybe I should say when heritage conservation chose me, there really seemed to be only one program available for me to study at a post-secondary level. And now, of course, there's been a great flourishing of programs across Canada, including here at Carleton. And Heritage Canada, the National Trust, is very proud to lead the National Roundtable on Heritage Education, which brings educators and trainers from heritage from across the country together annually to talk about how to improve and strengthen the field. In fact, our recent meeting here in Ottawa last October was hosted here at Carleton by the Department of Civil and Environmental Engineering, the School of Architecture, and the School of Canadian Studies. So we're pleased to be working with you in such an important endeavor. Clearly, more and more professionals and tradespeople are being trained and educated in heritage conservation. Much has been done, but there continues to be a deep need for architectural and engineering expertise tailored and customized for historic places. At the National Trust, in our work to strengthen the grassroots conservation movement, we're confronted daily with the need for solid education and conservation approaches, methods, technologies, and maybe even most importantly, attitudes. I'd like to tell you two mini stories that both have an engineering focus. Those of you who are following our media releases might have seen the recent story of the Ross River Suspension Bridge in the Yukon. It was built in 1943 as part of the Canal pipeline system to supply the Allied war effort, and it's an exceptional example of engineering ingenuity. That's a bit of a tongue twister. At 316 meters long with a 192-meter span, it's the longest suspension bridge of its kind in North America. Owned by the government of the Yukon, they consulted expertise and decided that they needed to take that bridge down. The community reacted. It's an important local landmark, and it obviously, although not formally designated, has national historic significance. Engineers from across the country rallied and offered their expertise, engineers who had experience working with bridges of that type. And ultimately, the government of Yukon has relented, and they're now putting together an RFP to engage appropriate conservation engineering expertise for the bridge. The second story is the old Mackenzie Seeds building in downtown Brandon, Manitoba. So this is a historic building that it was going to be redeveloped into a mixed-use residential complex. The price was right, and the province and the city of Brandon stepped in with great tax incentives to attract a developer to the project. So acquiring the building for the developer was certainly the easy part. What he found out, he experienced some real challenges in finding the right expertise in that part of the country, and ultimately burned through a couple of architects and 3 engineers before finding a team, bringing in expertise from another city that would be able to help him deal effectively with the rehabilitation of this building. So both of those stories, I think, demonstrate the challenge and the importance of having expertise. It's not uniformly available across the country. In fact, in the province of Saskatchewan, they've basically recognized the lack of expertise and skills in heritage conservation as a crisis for them. That they're really very challenged to be able to bring expertise to bear on projects. And I think the other important point is that the challenge in bringing the right people together for a project can actually poison the attitude of governments and property owners toward heritage. We know it's challenging. Historic places can be challenging and complex, and it's even more frustrating and challenging if the people that you expect to know how to deal with these structures really haven't been trained in the particularities of historic construction techniques and systems. So, all that to say, congratulations to all of you for the work that you're doing. It's a pleasure to be here in the halls of academe, and it's such important work. And for the lecture this evening, just another step in raising awareness and increasing expertise in heritage conservation. So, thank you very much, and enjoy the lecture.
Thank you, Ms. Bull. It gives me great pleasure to invite my colleague, Professor Mario Santana, to formally introduce our speaker and to request her to deliver the 2014 John Adjeleian Lecture. Mario?
I remember when I first met Claudia, and we met in a conference some time ago, I would say, and we were, what I would say, very young, because we are still very young, I think, professionals emerging in this very challenging field of safeguarding built heritage. And she had just started working at the Getty Conservation Institute, and I was actually starting to teach at the University of Leuven, and I was actually also working at UNESCO. And we have crossed paths many, many times across these times. But I remember in particular when I was about to move to Carleton, Claudia sent me an email and said, I have a project somewhere in Morocco. It's a very nice place, the Kasbah of Taurir. Would you like to come and, do some documentation with your students? And I said, I'm moving to Canada. Would you mind if I bring some Canadians along? And she said, yes, certainly, let's do it. And also my colleagues in Canada at the university entrust me with the idea of, joining the Getty and going to Morocco with some students. And it turned out to be an excellent learning experience for all of us, and the students in particular. Claudia's career is very extensive in the field, but I would say it's important to mention that she graduated from the Architecture and Urban Planning School at the Universidad Ricardo Palma in Lima. She attended ICROM in Rome, where she obtained a certificate in conservation, as well as the Business Administration ESAN in Lima. It's a certificate in business administration. From 1996 to 1999, Claudia was a member of the architecture faculty at the Universidad Peruana de Ciencias Aplicadas. During this period, she also practiced preservation architecture and had many projects in several Peruvian cities. Claudia earned a Master of Science in Historic Preservation from the University of Pennsylvania at the Historic Preservation program there. In 2002, as I said, joined the Getty Conservation Institute, in which she is now the manager of the Earthen Architecture Initiative. It is an honor for our Architectural Conservation and Sustainability program, and I'm also very thankful to Natalie to mention that the program is there. It's a cross-venture between the School of Architecture and our Department of Civil and Environmental Engineer. It's a bachelor's program in both engineering and architecture, and it's quite an excellent initiative, I think, in Canada. And I also want to thank my colleagues at the John Adjeleian Committee, because, they also entrust me to invite somebody, and I'm sure that you will be enlightened by the presentation of Claudia. She's a scientist and a passionate in our field. As I said, Carleton is also witness to her endowment to education. Many of our students have enjoyed opportunities offered by Claudia. I'm sure you will enjoy the engagement, scientific, and social dimension of her work. But I also have to say that she's the first woman to present in this lecture series, which is also important, especially when we're trying to get more female students in our engineering program. She's also the first architect, as Jack mentioned, and he's also the first Latin American to present in this series. So actually, it's a whole, I'm very excited about it. For these and many reasons, we should be all proud to welcome her at Carleton. So thank you, Claudia.
Well, thank you, Mario. It was a very sweet introduction. Before I start, I would like to thank the presence of the Peruvian ambassador, Mr. Jose Villina. It's an honor for me that you attend a lecture, as well as the cultural attaché, Mr. Jose Ortiz, also from the Peruvian embassy. I also would like to thank the presence of the Paul Van Gil, the chair of the Department of Civil and Environmental Engineering at Carleton University, as well as Rafi Gogray, I'm sorry if I didn't pronounce it properly, the dean of the same department. I also want to thank Jack Humer, who was the lecture organizer and a member of the committee. And I really would like to thank the committee for inviting me to give this lecture and to be with all of you today to show part of the work that we do at the Getty Conservation Institute. And last but not least, I would like to thank my friend and colleague of many years, Mario, who has been really a pleasure to work with in the last couple of years. And I should say that also the Getty now has a really high opinion about the program at Carleton University for the work that he and his students and his consultants have been doing. So after this introduction, I just would like to tell you honestly that the ultimate objective of this talk is to get more engineers working in the field of heritage preservation, because we really do need them. We do need architects as well, I'm not saying no, but I think we lack a lot of engineers, so I hope this talk inspires you. So first I'm gonna talk a little bit about the Getty. And the Getty has 4 institutions. One is the museum that has 2 locations, one in Los Angeles above Brentwood, and the other one is the Getty Villa in Malibu. There is also the Getty Research Institute that is an institution dedicated to the history of the visual arts in general. The foundation, that is an institution that gives financial support for special projects all around the world, and the Getty Conservation Institute, that is the institution where I work. The Getty Conservation Institute, or the GCI, has 3 departments. Has the education department, the science department, and the field projects department. And sometimes these 3 departments work together. Sometimes we do have projects that we run independently. So they are like a lot of collaboration between all of them. The field projects department, that it's where I work, I work within that department, has a series of projects. We have a total of 22 projects, that are around 25 countries around the world. We just started our Conserving Modern Architecture Initiative. We have organized a colloquium to kind of identify what are the needs in the field. We also start working in the Salk Institute of a masterpiece of Louis Kahn. We have been working at the Eames House, that it's a house that is located, a modern house that is located in LA, and we have organized also a colloquium to try to identify or try to design some of the guidelines for architects to design within the historic environment, that it's a topic that it's of very much importance. We have a small section of recording and documentation, and there we have been dedicated to develop inventories. The latest one is Arches, that is an inventory system that is open source, that allowed many institutions to actually be able to survey and document their sites. We have an initiative of historic cities and urban settlements, where the project in Morocco, that Mario showed some pictures already, stands, as well as we work with the Organization of World Heritage Cities as part of their conference. We also have projects that deal with archaeological sites and conservation and management. We are working on the conservation of the King Tut in Egypt, and we are also working on the management plan for all the tombs on the Valley of the Queens. We also have projects that are related with conservation principles and methods. We have been working for over 20 years with the government of China, and we have developed the China principles, that are a set of principles that the Chinese are supposed to follow to take care of the sites. And lately we have been doing a capacity study of the visitors of one of their sites, that are the Mocao grottos. We also have a lot of experience working with decorative surfaces. We have a big initiative that is called Mosaicon, that basically have training courses and a series of components for the conservation of mosaics. And we just finished also restoring a mural from Siqueiros on Los Angeles, the America Tropical. We have a project in Italy, in Herculano, for the reattachment of some of the plasters. We have an initiative on rock art. And then we have a section on building materials that at this time we have, we organize a course at ICROM in Rome. That is it's a conservation of stone. We have been doing this for the last four courses, and it seems like we are going to continue. And that's something that maybe some of the graduate architects and engineers would like to attend, because also for stone there is a lot of need of engineers. And then within the building materials, there is the Earthen Architecture Initiative. So that is the project that I am going to talk a little bit now. And then within those, I'm going to show 2 examples of projects. So the first question is, why it's so important? And I mean, why earthen architecture is so important? And basically, soil has been a primary material since the man learned how to build houses and cities. And that was almost 10,000 years ago. So it was the material of choice to do that. And it had to do with the fact that it's easily accessible, but at the same time, now there's a lot of attention to earthen architecture because it's extremely sustainable. As you can see in this diagram, basically you take earth from the earth, you build, and then at some point the earth goes back to the earth. And so it is that concept that create these buildings. And it was used all over the world from the early ages. This is Cliff Palace and in the Mesa Verde National Park in Colorado in the United States. And this site has earthen plasters that were done with a specific type of soil. And this is from the 4th century. And then we have, for example, another site, Huaca de la Luna in Peru, that has also not only decorated surfaces made of earth, but also all the pyramids are made of adobe that belongs to the Moche culture in Peru. And this was built between the 1st and the 8th century. We also had the Citadel of Bam in Iran that unfortunately got damaged by an earthquake in 2003. But this is one of the largest used citadels made of earth, and it was built in the 7th century. We also have the archaeological complex of Chan Chan in the north of Peru. This was built by the Chimu culture after the Moche culture in the 9th century. It has an area of 20 square kilometers. It has 9 palaces, and this is the main palaces, the Shuri Palace. And we also have the Mosque of Jenne that was built between the 14th and 15th century. They don't know exactly the dates, but it's around that period in Mali. And then we also have these villages in China that are also made of another type of construction that is earthen construction that is round earth, and those buildings are in use right now. We also have villages of the Bandiagara Cliff that are in the Dongo country, also in Mali. Those are like 289 villages made of earth that are actually in use. We also have earthen materials in some of the palaces in Bhutan, not only the plasters, but also the mortars. We also have other type of villages in West Africa. This is in Ghana, that is very peculiar for the type of decorated surfaces that they do have. We also have another site in Morocco, Said Ben Hadoud. It's a World Heritage Site that was apparently built in the 17th century and is very close to the area where we work with Carleton. We also have, for example, this type of constructions. This is the Cathedral of Lima that has all the vaults made of earth, and it is a mixed system of quincha construction that is wood with mud and also with mud plasters. And you can actually have this type of ceilings that, I mean, I'm going to explain where they came from, but you also have many residential houses this is the historic center of Lima, also made of earth, the first floor in adobe and the second floor is in quincha. You also have, this is the fort of Haili in Abu Dhabi. That is a fort that was recently restored and put for new use. This was original also from the 19th century, and this is the Church of Andahuaylillas near Cusco in Peru, that has is not only built on adobe, but also has all decorated surfaces made of earth, not only on the walls, but also on the roofs. And you have also, for example, this is a village in South Korea that is also made of earth. And, but earth is also used to build new construction in some areas. This is a school also in South Korea that's completely designed on earth. And this is the area of the dormitories that are part of that school. So it's also good for new construction. And you also have the architecture of Hassan Fatih in Egypt. This is a picture of that has that it's all made of earth. I'm sure you have heard about it. But one of the most fascinating things about earthen construction had to do with its social aspect. Like if you really look at all of these buildings I have shown you, there has been always a community really attached to them that has taken care of them, has preserved them, have renew them, because the nature of the material by itself is to be renewable. This is again the Mosque of Jenne in Mali, and this is a festival that happens like in February, around February every 4 years, that people from all the communities around Jenne come to the mosque with mud, and they themselves plaster the mosque, and they do this in order to maintain it and preserve it. In other circumstances, from the historical point of view, this is something that shouldn't be allowed. But because earth is a living tradition, it's part of the care and the maintenance of their buildings. The same happens in Peru. This is an image of people taking care of the church and also changing the roof, that it happens every 3 or 4 years. And it's really the community who always take care of them. So there is always this strong link between the community and the building that the community that take care of the building and that use the building that was made of earth, and so that is the social component of it. So for the Getty Conservation Institute, it's like many years ago we start this initiative for many reasons. It's not only that we want to work in these really beautiful buildings that you have seen, it's also because earthen architecture presents a series of challenges for the preservation of these sites. And it has to do with several reasons, but mostly had to do with the fact that we have lost this link or this connection between what the building is and the community that is supposed to take care of it. So, as you have seen, there are many World Heritage sites made of earth. Actually, 10% of them are made of earth. But earth, as I said before, is not a material that hasn't been used. It's actually a living tradition. Actually, 30% of the population live on earthen buildings. But as I said before, that presents a series of challenges. And particularly on the historic sites, there has been a lot of deterioration and lack of care. And that's the reason why 57%, more than half, of the World Heritage sites in danger are made of earth. And 16 of 100 sites of the World Monument Fund watch list are made of earth. So definitely there is this need of there is this problem of earthen materials and earthen architecture being deteriorated. So the question is basically, why? And as I said before, there is this lack of connection between the earthen building and the community, but there is also lack of understanding of how like the science behind earthen architecture. So the first thing that I think everybody needs to understand is that earthen architecture is made of basic soil. And a soil consists of an ensemble of discrete particles of various shapes and sizes. I'm sure you as engineers know this. The types, the relative proportion of these particles, and most importantly, the forces between them give a soil a particular character and behavior. So this is a chart, a very basic chart that kind of shows all the materials, all the particles that are part of any kind of soil. We have clay, we have silt, sand, gravel, cobbles, and the difference between the two charts, one is the US ASTM standard and the other one is from Great Britain. So sometimes there's some confusion about depending on which part of the world you are. And this is an image that I always like to show it because it kind of, this is more or less how it works. I mean, this is one of the beautiful plates that we always get in Morocco. And you can see there are like many different fruits with many different shapes and sizes. And soils behave like this. They are like this. They are composed like this. They are like different type of particles and all together conform a unit. And but the issue is how these particles interact with each other and what are the main components that make that the soil is useful for one type of construction or is useful for another. So if we look, and these are schemes are from Crater. This is this institution at the University of Grenoble in France that has studied earth as a building tradition for many, many, many years. So they became with these graphics that are kind of easy to understand. So the first one, if you see, it's like a soil module. And you see there is some clay, there is some sand, in some cases there is some gravel. If you look inside, you can see that there are different crystals. If you look inside, these crystals are like, it's a clay crystal and have some ions around. If you look inside, you're going to see that there are different crystalline units or sheets, and there is some space between those sheets. If you look at each of the sheets, you see that there are two layers, and there is ions between them, and this is actually where the water stays when you pour water into a clay material. And then this is what is the main component or the unique component of a layer of clay crystal. You have one layer of silicon, one layer of aluminum, and another layer of silicon. And you have a really strong bond between the layers. So these clay crystals can be three types. I'm sure you have heard about this. We have kyanite clay that is very stable and is the one that is mostly used for construction, and is very stable because the distance between the two layers is constant. We have, I'm going to just jump this one, as this marmorite is the opposite. It's extremely unstable, and because it has this distance that varies, that means water can come here and expand the clay. And we have alite, that its problem is it's stable on distance, but it has a lot of potassium ions. And those are the main three groups of clay minerals that we can find. And that's a very important component of any kind of soil. So if we look under the scanning electron microscope, we can see the same. We have the nodules. If we see inside, we start seeing the crystals. If we see even more inside, we still can see the laminar layers. And between these layers here is that you have this really strong bond within them, but also is where water gets in. And this is the other very important component of a soil for construction, and is the amount of water that you put on. I'm sure you are aware of the forces that applies when you have two elements joined by water, and that's exactly what happens in a soil for construction. I'm sure you have seen people, there is this famous movie, The Ghost. You see the clay scene and all that. So basically, there what you have is probably a very stable clay that has had a lot of water put on it. So there is a lot of clay and dispersion, and that allow to shape the base of whatever you are doing in a certain way. so it's much more plastic. When you start using the same soil for construction, you have to start managing the amount of water with the clay, but also the amount of sand and gravel. So water, despite the fact that for earthen buildings, people think it's a really bad thing, to build it is one of the most important elements. Basically, the difference between one and the other is like you have all the crystal dispersed, and you have a different force here than here. This allows you to move it. This doesn't allow you to move it because it's more strong. And there are a lot of tests that allow you to try to understand what type of soil you are dealing with in construction. So we have a lot of tests for soil characterization. We have granulometry, sedimentation, X-ray diffraction, scanning electron microscope, that is what the images that you saw before, ion chromatography. Then you have the Attenberg limit test. That is a test very easy to do in a laboratory that basically allows you to understand what is when a soil goes from the solid state to the semi-solid state, the plastic and the fluid, and then you also have water absorption by total immersion, capillary action, and all of these tests allow you to characterize a soil. And this is a chart that is used by the USGS, it's United States Geological Services, that qualifies all soils in this triangle. And it allows you to see how much sand you have, how much clay you have, etc. But that type of classification doesn't really help to understand which soils are good for what type of construction techniques. So again, Crater, this institution in France, developed this chart where you have the amount of the proportion or the amount of the different particles in one side, and then here you have the state of hydratation. And if you mix the two, you can start finding soils that are suitable for certain construction techniques. So for example, if you have a soil that is sandy, has a little bit of silt and a little bit of clay, and you have gravel, and is sort of in the humid state but somehow dry, you can use that soil for ramp construction. No? On the other hand, for example, if you have a soil that has mostly silt and a lot of clay, and a little bit of gravel and sand, and is in a semi-soft state, that's a good soil for adobe. And you also have very similar configuration, but more clayly for the quincha, that is the technique that you need to put the mud inside. And all of those have different characteristics, all of this type of soils. So not every soil is good for building construction. I mean, it's not that we can go out now, take the soil that is there, although the snow and the rain, and then use it. There is a special configuration of all the particles that allow you to build in a certain way or another. So there are at least, I think, 12 recognized construction techniques for earthen materials that use these different type of soils. The first one is the dugout, that is, just carving within the earth, and this is an image of Cappadocia in Turkey. We also have compressed earth or ram earth, and these are images from the sites in Morocco. We have a stack earth. That's another very common construction techniques also in Mali, but this picture is from the archaeological site of Casa Grande in Arizona. And then you also have molded earth that are mostly adobes. And then again, this is an image of the citadel of Bam in Iran before the earthquake. And with the same techniques, you can build something like this, like the church of Andahuaylillas outside of Cusco. And this is what I keep calling quincha, because that's how we call it in Peru, but it has other names like pajareque. I think it's in Central America. And in English, I think it's wattle and daub. There are constructions also in England made of this technique. And again, this is an image of the Cathedral of Lima, that they did a an adaptation of this technique to be able to construct this type of domes. That is also used for some residential areas. This is, again, another house in the historic center of Lima, that the first floor is of adobe and the other two, in this case, are made of quincha. But the question is, like, if we have all this science behind how soils behave and how they are used for earthen construction, the question is always, why does it fail? And that is one of the, I mean, there are multiple reasons why it fails, but the Getty is concentrating in two, and those had to do with the projects that we are developing. So the first one is the seismic retrofitting project. I'm just going to check the time. Yeah, okay. So the Getty started working in seismic issues and earthen historic buildings in the 90s. And what happens, there was this big earthquake in 1994, the Northridge earthquake, that damaged a lot of the California missions. I don't know if you're aware of those type of buildings that were from the Franciscans, etc. And there were some retrofitting measures that were designed, but that were suitable for maybe brick buildings or stone buildings. And and earthen buildings have a particular, they were not particular characteristic. They were not really suitable for them. So the Getty started working, trying to identify some techniques to be able to retrofit the buildings. So based on that research that lasts around 10 years, we have these publications that you can find online and download them online for free at the Getty. But then the last publication, the guidelines, were actually out in 2002. And then in 2003, there was this big earthquake in Iran, in the citadel of Bam. And then there was another earthquake in Morocco in 2004, and then another one in Pakistan. So there were a series of earthquakes that start happening. So then the Getty started thinking, well, if we have done these guidelines, I mean, why these are not implemented in other regions? So in order to do that, we organized a colloquium at the Getty Conservation Institute, and we invited around 60 professionals to try to understand why these guidelines were not applied to other buildings. And we also invite engineers from Peru that has been working, and India, I mean both, that have been working on this subject for a very long time. So the conclusions of the colloquium was basically that these guidelines, although very effective, need to be adapted to other economic and social contexts, because they require professional expertise and they also require financial resources to be able to implement it. So in order to try to apply these techniques to other countries, the Getty started thinking, well, where can we work? And I was already working there. So, but then the Getty has worked also in Peru for many, many years. So they choose to work in Peru. It had nothing to do with the fact that I was Peruvian. So they decided Peru was a good choice, and had to do with the fact that probably you are aware we suffer from earthquakes. We have suffered, from the Inca periods. I mean, we have some records. I love this picture that is in the Cathedral of Ica, because it's after the 1745 earthquake, and for me, it's one of the first site assessments that you can get after an earthquake, because I mean, it's a painting after the earthquake, so you can see the people yelling. Then there is a procession with Christ to be able to stop. But if you look at the buildings, you can see there are some cracks on the arches. So if you look at it, it's really a site assessment. So it's one of the pictures that I like the most. And something that is also fascinating from Peruvian history, and has nothing to do with the fact that I'm Peruvian, is that from the moment, I mean, not only during the Spanish viceroyalty, but also before that, because we suffer from earthquakes, so Peruvians were trying, by try and error, basically improve their construction techniques. And it's something that the engineers have done for centuries. Every time there is a disaster, the only good side of that disaster is that there is an improvement in the construction technique. So the Peruvians did that during the Inca period, but we don't have records of that. But what we do have records is about the viceroyalty period. And in particularly after the 1746 earthquake, there's a big earthquake in Lima, there was this viceroy that was known for the name of Conde de Superunda, who actually hired a mathematician to do an assessment of the houses in Lima and to come up with recommendations on how to retrofit them or make them better, for more resistant to earthquakes. And Godin came with these recommendations, and it did change the construction techniques in Peru. Before that, the vaults and domes were made with brick or stone that are really heavy, and so they came up with this idea of using the quincha on the second floor of the houses and on the vaults, and it was actually an earthquake that created that system. So after that, it was mandatory, for example, to have some buttresses on the adobe churches so they will not collapse for out-of-plane failure. You can also find this type of buttresses also. This is from the Cathedral of Ica. So, and this system of quincha was developed that is very flexible, very light, and it was put on top of the adobe walls. And you can still find it in Lima. And it's basically composed of a wooden panel, cane, and mud plasters of different types. And in some cases, gypsum, and in some cases are decorated with painted surfaces. And that has allowed also, that was turned into, to be used as bulbs and domes and vaults in many, many churches in Peru. And this is and it's a very sophisticated system that was developed during the viceroyalty period in order to stand earthquakes, and allows you also to have this type of decoration inside the churches. So these churches are made of earth. So, but since then, we have suffered a lot of earthquakes, and unfortunately, well, not unfortunately, but in some cases, that turned us into, start building with concrete or brick or reinforced masonry, and kind of the tradition of building on earth was moved to the rural areas because it's still being used in Peru. And especially during the 80s, almost like nobody wanted to build on earth. But there was this big earthquake in 1974 that actually bring the engineering community, because they wanted to create proper codes to build on earth, to continue building on earth. Because the people in the Andes was going to continue building on earth anyway, so the engineers decide to do some research and some testing to be able to safely provide some guidelines to do that. But that was for new construction. It was not for historic buildings. So when we were in the process of deciding where we were going to work, there was an earthquake in Peru in 2007, in the south part of Lima. And there were a lot of sites that were damaged, not only made of earth, but also, you can see here, this is concrete, probably badly constructed, and that's probably the reason why it fell. So the Ministry of Culture asked the GCI to make an assessment of the damage on the historic buildings, and we did that. We visited 15 of the most significant sites, and we wrote our conclusions in this assessment that you can also download for free at the Getty website. And I have brought some copies that Mario will be on chair to distribute accordingly. So you can, there are not too many, but you can. So that was one of the first publications of this project. And it's divided in we have a chapter about how the earthquake was, then a little bit of history and evolution of Earthen architecture, and then finally the assessment of the type of buildings that were damaged by the earthquake. So from that assessment, we create actually the project, and that has these objectives. The idea is basically to design low-tech seismic retrofitting technique using appropriate materials and local expertise for Peruvian historic building prototypes that have the potential for wider application in South America. And that has a whole methodology. that is also developed with our partners. So at the beginning, we partner with a School of Engineering in Peru, the Pontificia Universidad Católica del Perú, that has more than 20 years working on earth, mostly for new construction. Then we partner with University College London because they had an expertise on developing computer or finite element analysis or modeling. And then we also partner with Carleton University for a specific component in one of the buildings. And we always partner with the state agency, in Peru, in this case, the Ministry of Culture. But then we also create this peer review group that basically is a series of engineers from different parts of the world and also engineers in Peru that meet with us at specific points of the project to let us know if we are doing something wrong. So we basically present the project to them and they gave us our feedback. And that was also a way of disseminating the project. The project has a methodology that had to do with, like, first we did a research, then we did analysis, testing, and design. Then comes the phase of dissemination, and at the end we have to develop, we are in the process of developing our implementation projects as model conservation projects. So we start with trying to identify building prototypes in Peru that had a wider, they were similar to other buildings in Latin America. We visit a series of sites, we rank them by a series of conditions, and then at the end we select 4 buildings. The first one is Hotel El Comercio, that is very close to the main square in Lima. Actually, it's very famous because it has a bar that is called El Cordano, where all presidents and president's wife at some point have gone there. So it has a whole history, and it's very significant. And then we choose also the Cathedral of Ica, that was damaged by the earthquake. We choose another ecclesiastical building. This is the Church of Cuñotambo, where Carleton has been actively working with us. And then another residential building, this time in the Andes, in Cusco. And the difference between this one and this one is this has the quincha floors, and this one is 2 adobe floors. So they all have different construction techniques. So I'm going to show very fast what we have developed for at least 2 of the 4 buildings. We have developed for 4 of them, but if I show everything, it's just going to be way too long. So the first one is the Cathedral of Ica. We did all the architectural survey, not with Mario. This was done with local professionals. And we did a site assessment after the earthquake. And we also used some non-destructive techniques. For example, if you see the first 2 images is Hotel El Comercio. And one of the main problems that we did have is the engineers wanted to know exactly the position of the wooden post to be able to reproduce the model. And unless you take out all the plaster from both sides, you would never know where the posts are. And so what we did is we used the thermocamera to be able to identify. And I don't know if you see them, but here you can see the wooden post behind the plaster. And we use the same to identify the wooden arches at the Ica Cathedral, that you can see them there. So after we had we did non-destructive survey as much as we could, the engineers really needed to know exactly how were the connections between the different structural elements, something that architects don't like to do because it's like you are damaging the building, but the engineers insist. So I have to go through all the permits with the Ministry of Culture to be able to open up the building in a very methodological way. So we did that. And we look at columns inside, we look at corners, we went to places you could not possibly imagine. And at the end, we had the general configuration of the site, all documented and measured. And this is the other site where we have been working with Carleton. This is Cuñotambo. This is a small village of around 500 houses, 2 hours south of Cusco. The beauty of the city is that it's all made of earth. It's very authentic. There's no building on concrete. That is really good for us. And it has this beautiful church that one of the most important things is that this church has never been modified. So how the Spaniards built it, that's how it is. So, so we choose this particular church because, what I said, it has not been modified, and it was very typical of the churches in the Andes. And one of the challenges is that it has these beautiful wall paintings. And most of the engineers will agree with me that when you have to retrofit a building, it's very difficult when you have to retrofit it without touching the walls. So that was a challenge we wanted to address, the fact that what do you do when you have wall paintings and you cannot remove them? So, so we did the same, the architectural survey, not with Mario, with local professionals. We did the openings, and we came up with the general structure of the building, no? And then these 4 buildings were later recorded in the next publications that that also I brought some here, but then I also gave some to Mario to distribute accordingly. So we have, we call it a construction assessment that basically describe how these 4 buildings were put together. And then we have our first meeting with our peer review committee. And and they are all using Peruvian shirts because at that time the Peruvians were playing, I don't know, the Latin American Cup or something, and they were almost winning, something that never happens in Peru. So everybody was like really excited about it. So then I bought them T-shirts, and they wear it with the Getty banner. So they were like really. And then we visit the sites, but then we also have a series of meetings where they evaluate the methodology that we have applied for the construction assessment, but also for the testing and the modeling. So then, once the peer reviewers approve the procedures for the modeling and the testing, we start the testing and the modeling. We did granulometry for all 4 sites. We also then did a lot of wood identification and wood testing for also 2 of the 4 sites that has wood. We also developed this displacement testing at Católica University. We reproduced the quincha panels of El Comercio, but we also got lucky enough to get, it's not lucky, but it's not luck, but one of the houses was, historic center was collapsed and they were gonna demolish. And they have these historic quincha panels. So we were like, no, don't break them, don't break them. So we took the quincha panels to Católica and then we test them. Also, we test also historical materials. And we did the typical, mechanical test for mechanical and structural properties for all 4 sites. There were around 300 tests that were run for a period of 1.5 years at Católica University. We did compression tests, actual compression tests in piles. For these, we reproduce the adobes, but we also use historic adobes. Like we were able to get some adobes from some of the houses in Lima, from the Ica Cathedral, so we were able to test historic material, diagonal compression, and then we also, Católica University developed this test that are called the pull-out test that allows you to actually understand how much a wooden beam can resist in an adobe wall. And this is something that has never been done in Peru, and that has to do with the fact that Peruvians, and a lot of people that work in conservation and conservation of earthen sites, we always think that, like these sites are just amazing, has stand so many earthquakes. But then when the engineers have to ask us for calculations or numbers, we don't have any. The only thing that we have is the proof that the building is still there after 300 years. But nobody has taken the time to actually reproduce and then go back to the test and then get some numbers so the engineers get happy. So we have been able to do that. And so these are more results of the pull-out test. And then at the same time, what UCL did with the data from the construction assessment report is they build this model, no? And probably you're familiar with this tool. We use Algor, that is this software that is that normally has been developed for concrete and steel buildings, but we were able to modify certain parameters and characteristics, trying to input some details of the materials. So all the data that was collected from the test was then transferred to the models. And then, you have seen these engineers. It's basically, with the reproduction of the models, you are able to see how a building behaves during an earthquake, and you can also understand what are the areas that need retrofitting. So this is sort of a tool of analysis. And the reason, or the way we did this is that in a way that anybody can reproduce that in Peru for if they want to do some intervention on their buildings. Then we did the same for Ica Cathedral. That this is not the latest version, but you can see how the wooden structure move in certain directions. And this was really difficult to construct because we actually have to reproduce or run a bunch of tests regarding the connections of the wood. And so we have to reproduce them, design the test, come up with the results, and send them to UCL. And then after that, we have started to come up with some retrofitting solutions, in this case for the Church of Cuñotambo, like very low tech, because Cuñotambo, is like a 4,000 meter above the sea level. So it's really high. There's no way like any engineer is going to go and stay there for the duration of the work. So we have to find things that are, materials that are locally available, so they can actually retrofit their church. So at the end, we will run the model, and this is a partial one. It's very small, so I can do it. But we will run the model with these techniques already implemented in the model. So they will have a scientific proof that the techniques work. So, but then in the process of doing this, we became really engaged with our Peruvian colleagues from the Ministry of Culture. And at that time, we also started partnering with Carleton University. And the reason we did that is because this site has these precious wall paintings, and we really wanted to be able to record them before any kind of intervention started. So we talked to Mario, that talked to Carleton University, and they were able to put together a program for them to develop the rectified photography of all the wall paintings. I'm sure this is a familiar image from some of the engineers. And one of the things that it was also really good is that Mario had the capacity, because he speaks Spanish, to actually engage even more our Peruvian partners. So they were actually working with us during the process. So it was a capacity building component as well in that project. And this is the result of that rectified photography of the wall paintings. And after that, we did an assessment that also students from Carleton participate of the wall paintings. We identified a series of conditions. This glossary is actually also made by Carleton students. And then we carry on the assessment using a system that is quite standard. You have the rectified photography, you put it in a sheet, you record the conditions, and then with that you can make a proper diagnosis. And the reason why we were so interested in doing this and engage our Peruvian partners is because in Peru, unfortunately, there is still this tradition, particularly in Cusco, that when you have wall paintings, what they do is basically they do some strapo. That means that they cut the wall paintings, they take it out, they repair the wall, and then they put it back. And that's an old technique for the conservation of wall paintings. And the problem with that is that then after, you can see the scars of the cuts, and that doesn't go away. And so we are trying to work with our Peruvian colleagues to be able to come up with a system where you don't have to do that in order to structurally repair the wall. So the next steps for this project is we are in the process of developing the construction documents for the seismic rehabilitation. So it's a project. And regarding the testing, we're going to produce another publication like this one that hopefully it will be done soon. It's a little bit challenging to write with the engineers, but we're getting there. We're getting there. So the second component that I want to talk to you is the Morocco project that I think you have seen some of the images already. So this project started in 2010. The Getty decided to also investigate this region where we have been working also in areas of seismic areas, building codes, etc. But we were aware that there was a whole, a huge amount of earthen sites, particularly south of Marrakesh. So we made a reconnaissance trip. We went and stay in the same place we stay with Mario when we go. That's the city of Ouarzazate, but then we travel all the way to Marrakesh and we visit a series of sites. This is Aïd Ben Hadoud that I have shown you already. We visit this is some details of the same site. And then in Ouarzazate there are two valleys, the Valley du Drap and the Valley du Dades. And I don't know if you can see it, but you see these little crosses? So these little crosses are all over here. Those are actually kashbas. There are some of these earthen castles, and they are all over here and here. And according to our partners, there are around 250,000 of those sites all over Morocco. So, so we visit some of them. These are images of, this is the Valley du Dades, that has a little bit different configuration of these kashbas. And this is some images of the Valley du Drap that we also visit. But one of the really important things of these sites as well is all the community that is around them. There is still a strong connection. People use these sites. Some of them are cities. Some of them are houses, and people are still using it. And there is all this economic aspect of this site, that you have these kashbas, and then around the kashbas, you have this palmyra. Like this is a palmyra all over, and then you have the earthen sites in between. And then the way these sites were used in the past is because they has a lot of agricultural activity. So that that was the most important economical activity of the region, and that with development and with Casablanca and Rabat become these important cities, people start abandon them. So because abandon the land, they also abandon these important sites. So the Getty decide, has a series of meetings with our partners in Morocco, and we choose one site to create sort of working with the local authorities to create a sort of a mobile project. So this image is an image of, I think it's 1960s, where you can see this is the site of Taourir. And you can see how important was this site for the entire valley. And it has a kashba, but it also has a city. So the project objective is to develop a methodology for the documentation, but because it's something that is lacking in the region, emergency stabilization and rehabilitation plan of the earthen kashba of Taourir in Ouarzazate. It involves, working with key players, and it's a kind of a small bite toward, developing an integrated project methodology that could be applied to the entire site of Taourir, but also to other similar sites in the region. So this site, as I said, has been very significant historically, but it's very significant until now for the people of Ouarzazate. And also it's very important because it's in the cross of those two valleys that I showed you earlier, the Valley du Dades and Valley du Drap. And as I said, it has an entire village attached to this site. So this is the Kashba, and it has its city that is called the Sart of Taourir. So the idea was also to work with local authorities. So the rehabilitation of the site involved the protection of the historic fabric, but also the adaptation of the buildings to modern living conditions. So this is an hotel that it was made of earth, but they put concrete. So it's like it has been a whole mix of materials. So we're trying to work with our colleagues to have a proper intervention and proper use of materials. This is the site inside. This is the area called the Stara that has four components: the walls, Stara East, Stara West, and I think that's it. And the workshops, that these are a series of buildings that are the north part of the area. The site also has another area that is called the kite residence that is mostly in the middle. That is also very important because it has these historic wall paintings, and you can see the condition of the site. But it also had an area, and the kite residence has these wall paintings at this level of detail. And now in April, Mario and his team is going to come with us to Morocco to actually do the rectified photography of these wall paintings and finish up the survey of the entire Kashba. That is quite a big task. This is another area of the site. This is the museum. And we were always intrigued because it's a museum, but it's empty. So when you ask what you're supposed to be to see in the museum, you're supposed to see the architecture. But I have never seen an empty museum. But it's very, very interesting to go through because you can see the spaces, but there's nothing else to see. So this is the site, again in 1960s, and again, this is the Stara area that I showed you before. This is Stara West. This is Stara East. These are the ateliers or workshops that they have, and this is the surrounding wall. And here there's an area that now is a mediatheque, and kite resident area is around here, and this is the museum. So it's like a whole, it's composed of several areas. So the first thing that we did is we tried to identify the evolution of the site because it hasn't been built at the same time. It was not all built in the 17th century. Some people said that it started in the 11th century. So we need to understand the evolution of the site. We have recently created this sort of 3D scheme that shows you the different phases, like which areas were built immediately after the original configuration. So we were able to identify which ones of those were recently built. This is the last one. So we also were lucky enough to find the last survivor, or the last person that was an inhabitant at the Kashba. And this man that you see here, he is now he's 100 years old. When we interviewed him, he was 99 years old, and we tried to got from him the history of how the site was constructed and which area was first or second. So we got all this information. Unfortunately, we got it in Berber because that's the language that they speak in Ouarzazate. So it took us another year and a half to actually find a translator of Berber to be able to get some information from the DVDs. But we got it. The other thing that we did is we developed these emergency interventions in the site. For that, we worked with this institution, Crater, in France. And so we were able to, work with circus personnel to be able to do some stabilization of the walls. We also were concerned about the rainy season and how we could actually deviate the rain so it got drainage properly. So we work with our colleagues from Morocco that are the Center for the Conservation of the Kashba that actually has its offices within the site. And it's quite impressive because there are only 4 people, and they are in charge of the 250,000 Kashbas in the region, but also other architectural heritage. So it's like, I don't know how they do it, but because it's a lot of work. So we work with them when we go there. This is other images of the emergency interventions. And then one of the main problems that we encountered when we were there is that they don't have a systematic way of documenting their sites. Sometimes they do it, in hand drawing plans. Another time it's photos. They learn how to use a it was not a total station. I think it was a theodolite many years ago. So it's just like we wanted to give them a proper way also to document and organize and make an inventory of their sites. So that's, again, when we call Mario, and that's when he went with his student to do the survey of the Stara area, that is this area that I have shown you. And it was a really productive time. I think we worked for over 3 weeks together. And at the same time, Mario was in charge of also doing some training for our Circas colleagues. So now they are able to do their own survey. They do have now a total station that they can use. And so they are receiving training, and they continue receiving training every time Carleton goes to the site. We also have, the typical teaching sessions in the class where Circas personnel was able to also work in rectify photography. So they were able actually to do the survey with them, and also work on the process on site. And they develop a series of drawings that are quite comprehensive. And they also did rectify photography, and I didn't add here all the 3D modelings that they developed to be able to do accurate plans, because I couldn't show you the photos because the photos really didn't show how it is, but some spaces are like literally like this. Like you don't understand what the previous owners were doing in space like that and like that. But the Carleton students were like champions, and I don't know how they did it, but they carried the total station and they went there and they made the survey. And sometimes when they couldn't use the total station, they just did the rectify photography, and with the software they were able to create the plans and elevations. And this was also with some consultants of Carleton, like Chris, we met. That work in Morocco with us as well. These allow us to have detailed elevations and cross sections that is really good because they are geo-referenced and etc. I think you have seen this picture already in the series of images that Mario showed you, because after the success of the first survey, we wanted to continue developing the survey and training the Circas personnel, so we called Carleton again, this time to do the survey of the Caid residents. And then the training continued with the Circas personnel, and also the rectify photographer in these really complicated rooms that Carleton students were able to get into. And at that time also, Carleton carried on the survey of the open spaces of the SAR. That was a challenge because people were coming in and they have the total station, and the kids were inside of the total station. It was just like a whole, because it was within the city, so the community knew what we were doing. Oops. And they developed this, again, another set of drawings, this time with the Caid residents. And at that time also we had the opportunity to engage the community in what we were doing. It was I think this was the first public presentation of the work that we were doing, and the community was there. And then we called Carleton again for another campaign, and this time to check on the training of Circas personnel, but also on trying to develop a more comprehensive project on their inventory and how are they going to organize their sites. So we continue working with that, and now we are going to add the museum and the Caid resident to have the complete set of drawings. And this last campaign, we also work a lot on the statement of significance of the site to be able to identify which areas were the most important areas of the site, and then and the ones that could be actually be removed. And this is quite critical because, as I show you in some images, they just, because it's a living tradition in Morocco, they really don't don't approach the building in the same way we will approach it, like, thinking that you are not supposed to modify it. It's like, they are like, there is the roof that is, has some problems. I say, but that's not a problem. We will redo it, and we will repaint it. And it's very difficult to work in a situation like that because it's a living tradition, but at the same time, you try to respect the historic fabric. So it's always a challenge. But we were able to, together, identify the areas that are more important, write a statement of significance, and what we are doing next is doing also a condition assessment of the site, but it's more like a structural condition assessment of the site. And the idea is to be able to come up with a program for a proper use of this enormous site that has, this significance in the region. So it's quite challenging, but at the same time, it's very rewarding. And I think we have created a really good team with Carleton students and Mario and Chris. So hopefully we will be able to provide a better outcome of their designs. And this is not one of their designs. This is the same museum that I showed you before in Abu Dhabi, the same fort that they actually remodeled it for a museum. So we're showing it as a case study. And we are doing this also with the intention for them to properly allocate more sensible uses to the site than this empty museum, or like sometimes they rent this patio for rock concerts. And so it's a little bit out of, like it needs to be an integrated plan for reuse. So I think that will be, like I wanted to show you two projects from the Earthen Architecture Initiative, and but I think, it's late, and so everybody's hungry, so I didn't, I thought that it was a good image to finish and to thank. Really, it has been an honor to be here to show the work that we are doing. And finally, I would like to let you know that here there are some brochures of the work that the department is doing, so you can take some of them if you want on your way out. So you can actually know what do we do. So thank you very much.
Thank you, Ms. Cancino. I'm sure you will take some questions. If there is not much time, but we will take some questions, and then you will have a chance to mingle and speak to her during the refreshment break in the evening. So if you have a question, please use the microphone there.
If I may, I'd like to ask a couple of questions. One is a subject of much fascination for me, and that is cultural landscape and materials used. One can capitalize on it for the sake of tourism or simply to promote a certain site. Are you doing any research in this particular subject? This is one question. The other one is sustainable development. If there is resilience in materials that is known, and if there is a market for it, could that be used for alleviating poverty in many parts of the world? Thank you.
Okay. Well, regarding the first question, if I understood correctly, you were asking if we were taking advantage of the landscape of the...
Cultural landscape and materials. A street in Europe, in an old city, looks different how it is paved as compared to in a new part of the world. Is there anything at all that has been done or is being done whereby one can say that let's preserve not just a building that has collapsed because of earthquake or whatever, but also to preserve the quality of the landscape, the cultural landscape that is due to the material? That's the first question.
Yes, it's a very challenging area because, as I explained a little bit in one of the slides, the economy of the region really sustain the sites. That's how it was in the past. Like you have the Palmerie, and people were living from it, and there was a lot of exchange, and there was the caravan that came, and there was commerce around. So there was a whole economic activity that with time got lost. And so now what we have is the landscape, and the kashbas, and in some cases the SARs that are occupied, some of them, and some of them are not. So the GCI particularly is not addressing that problem in this project, but the Moroccans have done that in the past. So for example, the Palmeries are all protected by the national state as part of the cultural landscape of the region. So at least that is happening, but we don't deal with that aspect yet. No, we don't do it. And it's not that because we don't think it's important, it's that the GCI is very conscious about what is our expertise, and if we don't have the expertise in-house, we just don't carry on the project until we get the expertise in-house. So that's how, and then your other question about the sustainability of the material, I think we do agree that I think for us is not only an important aspect of earthen architecture, but it's also, there is a really strong connection of developing that and also preserving the material, because the more you use it, the better it gets preserved. But again, we are the Getty Conservation Institute, so we not necessarily deal with that aspect of the project.
Thanks for a great presentation. You were talking towards the end about preserving a heritage fabric in the context of a building that is being used by people for their modern daily needs. And I'm thinking back to a visit I was lucky enough to have to the Hagia Sophia in Istanbul, which is, I think, 1,500 years old, more or less. And it's been used as a church, as a mosque, and a significant building in Istanbul for all its history. And there, where they're doing preservation, they have a problem of saying, well, do we preserve the stuff that was done to this building 500 years ago, or do we go back to the original condition, or something in between? And basically, that points to saying, well, what people are doing to your heritage structures today is going to be the heritage of 100 years from now. So how do you balance that tension of, do we stop them from changing it and keep it the way it was, or do we let them change it so that we have new heritage 100 years from now?
I mean, I think it's a very complex. It's a theoretical problem, because particularly for earthen buildings, as I said at the beginning, they were meant to be maintained. They were meant to evolve. It's not that you build something on earth and it stays like that. Because of the nature of the material, you have to replaster, you have to change the roof, you have to do a lot of the things in the building. So it's very challenging when you have a building that is going to have a new use, because you have to adapt it to that new use, but you also have to understand that it's part of the evolution of the building, especially where in places like in Morocco or Peru, where there is a lot of a living tradition with that material. So it's not that there is nobody that could build on earth. They're like, they all do it. So it's very challenging. It's not the same approach that you will have to, I don't know, like a stone castle, that has its prime during the 14th century. Well, you go back to that. I mean, it's not that simple, but you go back to that period. With earthen materials, is a little bit complicated. And I mean, and there are other cases beside, buildings made of earth, where you actually have to take conscious decision about what to do, because you also have to acknowledge the fact that the building keeps evolving. But I think as long as you respect the fabric and the main intentions and values of the site, I think you can make some adaptations as long as you respect the original intention of the building, I think. But it's very challenging, and it's not a decision that is supposed to be made by the architect or the engineer of the conservatory. It's mostly a decision that needs to be made by the community, because it's a building that belongs to the society. So it's complicated.
Thank you very much,
You're welcome.
Ms. Cancino, for accepting our and for sharing your fabulous work that you are doing with Getty Conservation Institute and with Mario and his students from Carleton. And I'm very happy that they have been so helpful to you. And they faced all the challenges you threw at them. So as a token of our appreciation, on behalf of the department, the Carleton University, and indeed on behalf of all of you, I request our chair, Professor Paul Van Giel, to present you a few small gifts. Please join us here.
First of all, on behalf of the Department of Civil and Environmental Engineering, I would like to thank Claudia for an excellent presentation to take us on a journey from the octahedral and tetrahedral sheets of a clay particle all the way through to some outstanding earthen structures is quite a miracle to put that all together. It was very excellent. And it's also very great to see this work. It makes the department, myself as chair, very proud to see Mario and his team working so closely with the Getty Conservation Institute. So thank you very much. On behalf of the department, we have a few small gifts, and I'm not even sure what's inside all of the gifts, but one gift I would like to point out is that each year, for each of the speakers, we have a plaque that we prominently display in our department, on which there will be a little name tag put there as you for the 2014 speaker, and it has the same image that is on this plaque that we're going to give you today. It's a building that John was involved in designing here in Ottawa in the National Arts Centre. So thank you very much.
Thank you. Thank you. Oh, so nice.
And here are a few other small.
Okay.
But
Okay, thank you.
again, on behalf of everyone here today, it was a very good talk, and thank you very much for accepting the invitation to come and give this presentation.
Oh, no, thank you. Thank you.
It's our tradition that at this time we recognize some of our outstanding graduate students who have won awards. And I'll ask Professor Yasser Hassan to help us give the awards. Also request our president, Dr. Roseanne Ranche, to please join us here in the front. And Mrs. Elizabeth Adjeleian. Elizabeth, where are you? Oh, please.
Thanks, Jack. It is my pleasure to recognize 14 of the department's students, graduate students who won awards for this year. And I'll start with the winners of the John Adjeleian Graduate Scholarship. We have 2 winners this year, Amir Tehranian and Pedram Murtazafi. Jag Mohan Humar Graduate Student Fellowship for Civil and Environmental Engineering, and the winner is Abdul Qadir Abdul Rahman. Atta, can you please come and join in presenting the award? And we have Professor Atta Khan, Sustainable Transportation Graduate Scholarship, and the winner is Matthew Whelan. Van Bots Construction and Ferguson Neudorf Glass Scholarship in Recycling, Salah Sarhat. Bill Hirsch Memorial Graduate Scholarship, Shabnam Mizani. Wilda Blanche McDermott Holben Memorial Scholarship, Hussein Burak Gunai. Jean Ruptash Memorial Fellowship, and Dina Migala. International Bridge Builder Scholarship, Thina Thayabaran. SFPE National Capital Region Chapter Scholarship for Fire Safety Engineering, Sabah Ali. Queen Elizabeth II Graduate Scholarship in Science and Technology, Christopher Huss. And every year we recognize some of our best undergraduate students who are joining our graduate program, and we offer them the graduate scholarship in civil engineering. And this year we have 3 winners, Ahmed Hassan, Ryan Golich, and James Doyle. Thank you very much.
That brings us close to the ceremony or the event. At this time, I'd like to express my thanks to a number of people. First of all, I want to thank our committee members, Professor Abdul Halim, Mario Santana, Professor Abbas, Brahmaya, and of course, our departmental secretary, Kay Castleman, and Sarah Fay from the Advancement Office of the University, who put in countless hours making this a successful event. And at the end, of course, most of the thanks go to you for coming down to this lecture and listening to Ms. Claudia Cancino. Thank you very much. We have some reception in the atrium outside. It's a beautiful site, and you can overlook the river. Please join us there. Thank you.